All right, another algebra example. This one is also a type of radical equation because this equation x plus x to the power 1/2 equals 6. That x to the power 1/2 is the same as a square root of x. So it's equivalent to this. So yeah, it's radical, like the last one. It has a radical in it, right? But in this case, I'm going to show you how to solve this equation in a slightly different way. We could do it the same way we did the last one, where we isolate the radical and then square both sides. But there's another way to do this using an idea called U substitution, which is a super important concept for calculus and for learning about functions. It's so important. When we get to function composition, that's essentially the same subject, same idea. And when you get to calculus, there's an entire strategy you learn called U substitution, or just substitution. You don't have to use the letter U, but it's traditional. Yeah, it's a very important concept. So I'm going to introduce it in this example. So the idea is to notice that x is actually the same as the square root of x squared, right? Because the square root and the square would cancel each other out and give you x, but we can write it as the square root of x squared. And doing that kind of shows us, I'm going to use parentheses here just to like really kind of highlight this. It shows us that this is basically an equation, like a quadratic equation, that you've substituted in the square root of x in place of whatever variable you had there before. So this is where this idea of U substitution comes into play. We're going to use the letter U as kind of a dummy variable that's just going to stick around for a little while, and then we're going to get rid of it again at the end. So we're going to come in here and say, let's let U, this is a new variable that we're just introducing out of nowhere, let's let U equal the square root of x. And so the U is we're introducing it out of nowhere, but we're defining how it's related to x, right? We're just saying, let's establish this relationship. U is equal to the square root of x. Well, then I can rewrite this equation as U squared plus U equals 6, which is a much simpler equation to solve. So let's go to step 2 and go about solving that equation. First thing I want to do is actually subtract the 6 from both sides, because I would like this to equal 0. That's often the best way to begin, is by getting your equation to equal 0, so that you can do some, say, factoring or apply a quadratic formula or whatever. Again, this is a nice easy one to factor. I'm kind of keeping it simple here so we can focus on the more abstract concepts. No need to go crazy with difficult algebra when we're just trying to learn U substitution. All right, so U plus 3 times U minus 2 equals 0, and then we get those two possible solutions from that. U equals -3 and U equals +2. So here are two possible solutions for the value of U. But we're not done solving our original equation, because our original equation was in terms of x, right? So what we need to do now is undo our substitution, go back to the world of x, and then figure out what x would have to equal. So recall this relationship. U is the square root of x. So if U is equal to either -3 or 2, then the square root of x is equal to either -3 or 2, right? Okay. So now let's look at each of those possibilities one at a time. First of all, the square root of x equals -3. This is impossible if x is a real number, right? You can't have the square root of a real number is a negative number. Remember that this radical symbol, that square root symbol, always denotes the positive square root. There is also a negative square root, right? Every number has two square roots, positive and negative, but this notation indicates the positive one. So we can't get a negative square root of x value, right? So that answer is just straight out. There's not going to be, that possibility is we can just throw it away. There's not going to be any solutions to this equation that arise from that possibility. So we can turn our attention to the other one. All right, square root of x equals 2. That's fine. That's possible. Let's try to solve for x by just squaring both sides and get x is 4. There we go. That is the only possibility. And we can check it like before, we better check to make sure we don't have any problems. We can stick it back into the original equation. 4 plus the square root of 4 equals 6. Is that true? Well, the square root of 4 is 2. And yes, 6 equals 6. So there we go. 4 is the only solution to that equation. And we got there by using this U substitution strategy.